Hi, hello guys, this is Vijay, chemistry lecturer from Ayalabad Junior College. As you know that we have started our NEET series and we are discussing about each and every chapter in detail in chemistry as well as in biology. Okay, so now let us discuss some characteristic features of this anode rays. Okay, let us see one by one. Similarly, like these cathode rays, the anode rays also could able to travel in a straight line, and that could able to cast the shadow of the object which is placed in their path. So if there is a object placed, the path of this anode rays or the canal rays, that could able to show its shadow. Similarly, like the cathode rays, and this could also able to travel in a straight line. Next, the anode rays also having the deflected characteristic features. When these rays are deflected, when we are applying for magnetic or the electric field. So we are bringing a magnet or we are supplying an electric field around these rays. What happened? They could able to deflected. Similarly, like these cathode rays. Okay. But this deflection of anode rays is in the opposite direction to that of these cathode rays. Say for example, like these rays are attracted towards the negative plate, yes, and in the electric field, means these rays which are consisting of positively charged particle. Though it has the positively charged particle, they could be able to attracted towards the negative plate of this electric field. Okay. Yes, so this property also similar to that cathode rays, but this is deflection of this anode rays which is falling on the opposite direction. Okay, next point is like the cathode rays. These rays also could able to rotate the wheel, I mean a metallic wheel, when we are placing through the path of this rays, like earlier we discussed about the cathode rays. We are placing a metallic plate here in between this path of this cathode rays. It started to rotate because it possesses kinetic energy. So it has mass and velocity. They could able to rotate the wheel. Similarly, like these anode rays also, or the canal rays also could able to rotate the wheel which is placed in their path, and that could able to show that it has kinetic energy, which also have the heating effect. It's also having the heating effect. The charge to mass ratio for these rays are considerably smaller than the electrons. Charge to mass ratio, when as we are comparing to the electron, which is very smaller. And finally, the E by M ratio of the positive rays, which is depending on what gas we have taken in the discharge tube. Okay, the charge by mass value of the canal rays or the anode rays, its particle is basically depends upon the nature of the gas what we have taken inside the discharge tube. Okay, so these are the few characteristic features of anode rays. Discovery of cathode rays and discovery of anode rays and the discovery of fundamental particles, that could leads to the further discovery of the radioactive substances, and that these radioactive substances, they could emit different types of rays. So let us see one by one. This discovery of cathode rays and anode rays, they could able to show the atoms which are divisible into the subatomic particles. Yes, the earlier period, like Dalton's atomic theory, that could able to explain about what? See, the atom is the fundamental particle of the molecule, and that could not be divisible. But this statement was broken by the discovery of this cathode rays and anode rays. I mean the fundamental subatomic particles present in this atom. Okay. So this was further supported by the discovery of this radioactivity, and this radioactivity discovery credit goes to Henri Becquerel. He is a French scientist in the year 1896. So in the year 1896, Henri Becquerel, who could able to perform few experiments on these radioactive substances, so that leads for the different types of rays which are emitted from the radioactive substances. First of all, we should know the basic concept of what is the meaning of radioactivity. Yes, radioactivity is a phenomenon. Radioactivity is a process of the spontaneous emission of the active radiations by certain elements. There are some elements, they could able to produce spontaneous emissions of the active radiations. So this process we are calling as radioactivity. Now the substances or the elements which could able to emit such a radiations are called radioactive substances. There are few examples for these radioactive substances, like uranium, radium, polonium, thorium. So these all are few examples: uranium, radium, so these are the substances, or these are the elements, they could able to emit the continuous or spontaneous emission of the active radiations. Okay, so these substances we are calling it as radioactive substances. Okay, now the effect of magnetic and electric field on these radiations, let us see what could happen. So that experiment did by Henri Becquerel in the year 1896, he could able to observe the continuous emission of different radiation, different types of radiations. Okay, so by this experiment, what actually he did? This is the experimental setup by the Henri Becquerel, who could able to discover the radioactive substances. Okay, so what he did actually, he could able to take a radioactive substance in a lead block. This is lead block, and where he kept this radioactive substance, say for example like uranium. Okay, and this should be kept in a cavity of this lead block. The radioactive radiations that could coming out from this by a narrow slit, through a narrow slit, and these radiations are allowed to pass through a strong electric or magnetic field. So here we kept two different electrically charged plates or electrically charged particle, like positively charged and negatively charged. So through this slit, a small narrow opening, the radiation could able to pass through. What could happen? These rays are started to deviate or deflected according to the strength of this electric field and magnetic field. Okay, this deflection of these rays was, the deflection of these rays were recorded in a photographic plate as given in this figure. You can see. So this is what the photographic plate, fluorescent screen, and there we could able to record these deflections of these radiations. Now let us see what are the different radiations are emitted or emerged from this radioactive substance. When these rays are passing through a small slit, a narrow opening, where we kept this highly electrically charged particle, the rays which are started to deflected towards the negative electrode. Say for example, there are two electrodes we have used here, positive and negative. So if the rays which is passing through this, the deflected towards to the negative electrode, these rays are said to be alpha rays. These are considered to be alpha rays. Similarly, the rays which is coming through this narrow slit and where it is deflected towards to the positive electrically charged particle, that rays are considered to be the beta rays. Though the rays which is not deflected, which could able to penetrate through and that could be recorded in the photographic plate, are considered to be gamma rays. So alpha rays, beta rays and gamma rays. So these are the three different radiations could able to recorded on the photographic plate fluorescent screen by doing this, by performing this experiment by Henry Becquerel in the year 1896. Okay. Now, these alpha particle rays are the alpha rays that could have some, properties. So these rays were found to be consisting of positively charged helium-2 plus ion. Okay, helium-2 plus particles. So these rays are positively charged particle. Each particle which has the atomic mass unit AMU, its value, that is 6.6 into 10 to the power of minus 24 gram. That is what the AMU, atomic mass unit. Atomic mass unit. Yes. And this would carries 2 units of positively charged. So here we are going to consider this as positively charged, 2 positively charged particles. So these are the few characteristic features of these alpha rays. Now let us see these beta rays. These beta rays, that is straight opposite to this alpha rays, because these rays are deflected towards to the positively charged electrically charged plate. So these rays could have the negatively charged particles. These rays could contain the negatively charged particles, so which has the same charge by mass value as the cathode rays. Say for example, this is almost equal to the particles present in the beta rays are almost equal to the nature of electron. So these rays particles are equal to the nature of electron. Similarly, gamma rays, these rays which are not deflected at any direction, whether the positively or the negatively charged electric particles, and that could penetrate through and that is recorded on the fluorescent screen, photographic plate, and these rays are considered to be neutral. So though it does not have positive or the negatively charged particles, and they are considered to be neutral charged particles. And these rays recorded as high energy electromagnetic radiations which are having no charge and negligible mass, very less amount of mass, and it has high electromagnetic radiation, but there are no charge for this particular radiation. Now let us have a quick recap about this discovery of radioactivity. As we discussed about the discovery of cathode rays and anode rays, okay, and these discoveries leads to the further discovery of the radioactive substances. First of all, we should know the meaning of radioactivity. So radioactivity is a phenomenon where any substance or the element that could able to emit continuous or spontaneous radiations, that process is called radioactivity. The substances which are involving for this radioactivity are called radioactive substances. Say for example like uranium, radium, polonium, thorium, these all are the few examples for this radioactive substance. So now these radioactive substances, they could be able to emit different wavelength of these radiations. So how that could be possible? By performing this experiment. And according to this experimental setup, you see the radioactive substance that is placed in between the lead block, and there we have a small slit. So through this slit So through this slit, when we are bombarded these radioactive substances, say for example like uranium, radium, polonium, any one of the radioactive substance which we kept inside this lead block, and we bombarded this radioactive substance. So it started to what? It started to do continuous, spontaneous radiation. So continuous, spontaneous radiations of this substance is recorded by the radiation of this substance is recorded by a screen, a photographic plate which is placed in front of the radiation where it is falling. So there it could be recorded, a fluorescent screen. Now, when we are applying for a strong electrical field or the magnetic field by applying two different electrodes, the radiation which is passing through this slit could be able to deflect towards to right side or the left side. So how it is going to deflected? Say for example, certain rays could be able to deflected towards to the negatively charged particle, negatively charged plates, and such radiations or such rays are considered to be alpha rays or alpha radiation. Similarly, the rays which could able to deflected towards to this positively charged, electrically charged plate, what happened? These rays are considered to be the beta rays. And there are few rays, they could not be able to deflected either the positively charged or the negatively charged, electrically charged plate that could be able to go in a straight path, and this could be recorded on the fluorescent screen or this photographic plate, and these rays are considered to be gamma rays. So these are the three different radiations, and this discovery of radioactivity credit goes to Henry Becquerel in the year 1896. Okay, so now let us discuss about the one more fundamental particle present in the atom, I mean the subatomic particle called neutron. So discovery of neutron. So the discovery of neutron, after the discovery of this other fundamental particle like electron and proton, there is a need of the presence of electrically neutral particle as one of the constituent of an atom. Now you see, these neutral particles are called as neutron, and that was discovered by James Chadwick. Okay, so who would able to help to explain the atomic mass of an atoms? Okay, so actually how he discovered this neutral particle or the neutron? In the year 1932, he could able to bombard a thin sheet of beryllium element with the help of these alpha particles. Okay, and he could able to observe highly penetrating rays which consisting of the streams of neutral particles. So finally he would concluded that these neutral particles are called as neutron. Okay, and this would have the mass of, it has certain mass, the mass of this neutral charge or the neutron are 1.675 into 10 to the power of minus 27 kg. And this could help for the further study about atomic mass of an atom. So by this way the discovery of neutron would happen. Okay, so discovery of neutron is an accidental incident. So by James Chadwick in the year 1932, he could able to bombard a thin sheet of this beryllium element with the help of these alpha particles. He could able to observe the highly penetrating rays which is consisting of the streams of neutral particles, and these particles are possesses certain mass. That mass is 1.675 into 10 to the power of minus 27 kg. 1.675 into 10 to the power of minus 27 kg. So by This he could able to conclude that these neutrally charged particles are called neutron. So this could help us to find the further study about atomic mass of the atoms when we are discussing about, yes, the neutron value we are going to be considering. Yes. Now look at this table, you would be able to understand the mass and charge of the subatomic particles. Say for example, here are three fundamental particles, names are given with the symbol like electron, proton and neutron, and these are having the symbol of electron small e and proton small p and neutron small n, and it has the mass given in different kgs. Yes, say for example like electron, which has 9.10939 into 10 to the power of minus 31 kg, and similarly like proton you see 1.67262 into 10 to the power of minus 27, and neutron which has the mass 1.67493 into 10 to the power of minus 27. Proton and neutron mass are almost closer to each other. That is the reason the relative mass of these proton and neutron are considered to be 1. And similarly, like in approximate mass value for this proton and neutron are considered to be 1, whereas the approximate mass of this electron is not going to be considered. That is denoted as 0. And charge of this electron, this was discovered by Millikan's oil drop experiment. Yes, so that could explain in detail about the charge of the fundamental particles given, like electron you see 1.6022 into 10 to the power of minus 19 coulomb. Similarly for proton, that is almost the same, 1.6022 into 10 to the power of minus 19 coulomb. But there is only one difference between these two fundamental particles, though this electron possesses negatively charged, that is the reason the value given as negative, and the proton which possesses the positively charged, that is the reason the value which is given as positive. The relative charge of these three fundamental particles are like for electron which is -1, proton that is +1, and neutron that is 0. So this is what the mass and charge of subatomic particles, proton, neutron and electron. Okay, so far we have discussed in this class in detail about the discovery of cathode rays and discovery of electron. Similarly, we discussed about the discovery of anode rays and proton, and these anode rays are also called as canal rays, the another name for these anode rays are positive rays. And similarly, we discussed about the discovery of neutron. So discovery of neutron, that is the neutral particles present in the subatomic level. So that also we discussed the discovery of neutron. Similarly, we discussed about the discovery of radiation. So in that category we discussed about alpha, beta and gamma radiations in detail. Okay, yes. So this could conclude this today's session of NEET chemistry in detail about atomic structure, and this chapter we will continue with one more video with further more topic. Until then, thank you guys.